In this video, we are going to do two questions. These are the two questions from the chapter Real Numbers. Now, if I see the first question over here, it says if the LCM of two prime numbers P and Q is 2 to 1, where P is greater than Q. And what else we have to find out is the value of 3P minus Q. Now, what you should know here that these are prime numbers, right? So LCM of prime numbers like P and Q is given here is always the product of the number. I repeat that the LCM of two prime numbers, as you know that two prime numbers are co-prime, they do not have any common factor between them. So their LCM is what? The product of the number. So we can say from here that P into Q is what is equal to the LCM, and LCM is given that 2 to 1. Now check for the different prime numbers. We are going to do hit and trial method. So like 2 is a prime, 2, 3, 5, 7, 11, 13, right? I wrote few prime numbers over here. So 2 to 1 is not divisible by 2, not by 3, not by 5, not by 7, not by 13, so 11, but it's divisible by 13. So we know that 2 to 1 can be written as what? 13 into 17. But then you have to check here that in this case, it is given that P is bigger than P is greater than Q. So this will be P. That implies P is 17 and Q is 13. Now check what we had to get was 3P minus Q. So 3 times P, that is 17 minus Q. So this is what? This is 51 minus 13, which is how much? 38. Yes, we have an option C is the correct answer for this. Now let's check for the other question over here, the second one. So what we have to do here is in this question, it says the sum of the exponents of the prime factors in the prime factorization of 1764. So what we are going to do is to prime factorize this number, that is 1764. First I'll divide it by 2, 2 8 times, 2 8 times, and 2 2 times. Further it is divisible by 2, so it's 4 4 1. We know that this is divisible by 3, so it's going to be 1 14, that is 4 times 12 and 7 times. Continue to divide it by 3. Yes, it is divisible. This is 4 times 12 and 7 times. Okay, wait. 4 times is 12 and 27, right? So that is 9 times. So it's divisible by 7 now, 7 times. So what we have to get was the sum of the exponents. That means we have to add these numbers. That is 2 plus 2 plus 3 plus 3 plus 7 plus 7, right? So this is 5 plus 5, 10, and this is 14. That is what we have to get is the sum of the exponents. Okay, we made a mistake, but we can recover it. What we have to get is the sum of the exponent and not the prime. So it is 2 raised to the power. The first is 2 raised to the power 2. The next is what? 3 raised to the power 2. And the last one is it is 7 raised to the power 2. Then you have to see that we have to find the sum of the exponents, and the exponents are what? 2, 2, and 2. That means 2 plus 2 plus 2. That gives you how much? 6. So 6 is the correct option in this case. Let me see it again. The sum of the exponents of prime factors. Yes, the sum of the exponents and exponents are what? These powers, and their sum comes out to be 6 in this case.